Okay, let's talk through how to solve this inequality. So as you can see, we have a rational function is supposed to be less than 0. The first place that I would begin on this is I would attempt to factor the numerator and factor the denominator. So as we get going on this, it's nice quadratic, so I think this should factor pretty nicely. I didn't choose a super difficult one. I think the numerator should factor as x plus 5 and x minus 1. Check me on that, but I'm pretty confident on that factoring. The denominator as well should be not too bad. I think we have an x minus 4 and an x plus 3. Okay, we're not really allowed to just multiply both sides to get rid of our denominator. Because it is an inequality, this rational function, we're trying to figure out overall when is it going to be positive or negative. In our case, we're going to be looking for the negative overall results. Next, let's go ahead and figure out what values of x make the numerator equal 0. Well, we could set each factor equal to 0, or we could just kind of visualize if we were to plug in a negative 5 into this first factor, negative 5 plus 5 makes 0. Next, moving on, we have x is going to equal 1. On the denominator, we can think x equals 4, because 4 minus 4 makes 0. And finally, x equals negative 3 for that last factor. We're going to take these 4 values and we're going to go ahead and put them on the number line. All right, so let's put them in number line order, meaning we should really start with negative 5. The next value would be negative 3, then positive 1, and positive 4. So what we've done is we've split our number line up into 4 distinct sections, in between these values and to the left and to the right. All right, from here, what you want to do is basically we're trying to determine when these sections are positive or negative. So what I'm going to do is create a table to go along with this. And what I've done on my table is I've listed out all of our factors across the top here. And if you happen to have a repeated factor, meaning something was squared or the exact same factor occurred twice, just go ahead and list it twice. That's probably the easiest way to do this. Next, let's go ahead and pick out some test value in each section of this number line. So to the left of negative 5, I don't know, negative 10 fits out there. So let's make that our test value. When I write these, I also try not to write them on the same side of the number line as where I put the values that are going to split up our intervals. So negative 10, and now we need to test it in each one of these factors. So I think negative 10 replaces the x, negative 10 plus 5 makes negative 5. Overall, we just care that it's negative in that section though. And there wasn't anything special about negative 10. You could have picked negative 1000 as your test value. Next, we need to plug in negative 10 to this factor. So negative 10 minus 1 makes negative 11, but negative. That's what we care about. Negative 10 minus 4, negative 14, but the negative is the part we care about. And finally, negative 10 plus 3 makes negative 7, but negative is what we care about. Now, we just need to count up. We have 1, 2, 3, 4 overall negatives that are being either multiplied in the numerator or multiplied in the denominator. All right, so 4 negatives, an even number of negatives, is going to give us an overall result of a positive. All right, so this section of the number line out to the left of negative 5 is overall going to be positive. Now we just repeat this process multiple more times. We need some value between negative 5 and negative 3. Well, negative 4 is a pretty good value there. And then we'll quickly just test this, right? Negative 4 plus 5 is positive. Negative 4 minus 1, negative. Negative 4 minus 4, negative. Negative 4 minus 3, negative. So by my count, we have 1, 2, 3 total negatives this time around, which is an odd number, which means when you have an odd number of negatives multiplied or divided, it's going to be overall a negative result. All right, let's repeat 3 more times. All right, between negative 3 and positive 1, let's go 0 as our test value. All right, 0 plus 5, positive. 0 minus 1, negative. 0 minus 4, negative. 0 plus 3, positive. So I think we got 1, 2 negatives as we count them up. That's overall going to be an even number, therefore positive in this section of the number line. All right, next we go from 1 to 3. Again, we just need some, or 1 to 4. Let's go with 2 fits in there. 2 plus 5, positive. 2 minus 1, positive. 2 minus 4, negative. 2 plus 3, positive. So in this case, we only ended up with 1 overall negative. All right, so a negative times a bunch of positives makes an overall negative result. One more interval to go. Let's pick some value to the right of 4. Let's go with 10. I've run out of space on my table, but that's okay. We'll just make it at the bottom here. 10 plus 5, positive. 10 minus 1, positive. 10 minus 4, positive. And 10 plus 3, positive. Looks like we have, in this case, 0 negatives overall. All right, so that means a bunch of positives being multiplied or divided. So overall, that result's going to be positive. Okay, so at this point, we haven't cared at all about what the sign was, whether it was a less than, as ours is, or a greater than. In our case, because it's a less than, we're trying to find where is the overall value going to be negative, right? Less than 0. So I think ours works out to be negative between -5 and -3. And also between 1 and 4. All right, so those are the intervals we really want to focus on. Now, because ours did not have an or equal to with our inequality, that means we're not going to include the -5 or the -3 or the 1 or the 4. All right, I know these have different meanings along the way. The values that came from the denominator are going to be vertical asymptotes. So those never really get included. Same thing with the -3, vertical asymptote going on there, so it's not going to be included. But the numerator values, those would correlate with x-intercepts. So you have to be careful. Are we allowed to equal 0, have a y value of 0 for an x-intercept? In our case, because of the strict inequality, no, that's not going to get included, and neither is the 1. All right, so for us, looks like we have 2 intervals. Looks like we have one from -5 to -3. Neither of which was going to be included, so we'll use parentheses on either side. We'll toss a union in between, and then we have another interval going from 1 to 4. Again, parentheses on both sides because we're not including either one of those endpoints of our intervals. All right, so overall result, we're going to use both of these with a union in between. Now, if for some reason it had been a greater than 0 instead, you'd be identifying the intervals that got positives to go along with them and making those into intervals for your solution set. So I hope this helps out. Good luck as you're working on these and understanding inequalities with rational functions.